Hello, welcome to our YouTube channel. Today we are going to see the problem minimize permutation subarrays. So in this problem, we are given a permutation P of size n and we want to minimize the number of subarrays of P that are permutations. In order to do so, we must perform the following operation exactly once. So we can select integers I and j, then swap pi and pj. Okay, so we have to swap that. So for example, this is this array. So we choose I equal to 2 or j equal to 3. The resulting array will be this if we swap them, second index and third index. So that will be 5, 4, 1, 2, 3. So if instead we choose I equal to j equal to 5, then the resulting array will be 5, 1, 4, 2, 3. So with the choice of I and j, we'll minimize the number of subarrays that are permutations. So that is the question here. So let's say a permutation of length n is an array consisting of n distinct integers from 1 to n in arbitrary order. For example, 2, 3, 1, 5, 4 is a permutation, but 1, 2, 2 is not, you know that, and 1, 3, 4 is also not a permutation. So an array A is just a array of B if A can be obtained by from B by the deletion of several, possibly 0 or all the elements from the beginning and several possible 0 or all elements from the end. So we can do anything. Okay. So let's see some example. How can we solve this problem? So let's suppose we have 1, 2, and 3. So what we can do, we have to swap these values. Okay. So we can do swapping like this. If we swap like this, 2, 1, 3, that is one thing. And another thing that we can swap 1, 3, 2. Okay. So our main goal is to do this. We have to separate 1 or and 2 by the maximum. The maximum element should come in between. So that is our goal here. So how can we solve this problem? So we can solve this problem by having the index of 1 and 2. So we have index of 1. Let's suppose we have the index of 1 is this and 2 is this. This is one based indexing. Okay. And the maximum index. Maximum index is maximum element index is max. Okay. So we have these three variables. What we have to do, let's suppose if 1 and 2 both occurs same side, that it will be left side, like 1 is less than max and simultaneously 2 is also less than max. So then, and one more thing we have to see here, if the index of first element is greater than the second element, then we will swap the first index with the maximum index. So if this is the case, let me write. Uh, so if that is the case, first index that is greater than second one. So our answer will be first index and maximum index. And another case, if that is opposite of this, 2 is greater than 1, then answer will be 2 and max. So let it be both are coming on the right side. This time it is left side and another case will be right side. So in the case of right side, if 1 is greater than 2, then our answer will be 2 and max. And else condition, answer will be 1 and max. So if both these conditions, this one and this one, is not satisfied, that means they are already on the opposite side. So we will simply return n and n. The last the n we have given input. Our answer will be n and n. That will be the answer. So you can see what we have. If both are coming on the left side and the index of 1 is greater than index of 2, our answer will be 1 and the max. We will swap the 1 and the max. And if both comes on the right side, our answer will be if 1 is greater than 2, then we will swap 2 and the maximum. If opposite is the case, we will swap 1 and the maximum. And apart from these two conditions, if they are on the either side, one is on the left and two is on the right, or the vice versa, then we will have the answer n and n. So that is the solution for this problem. Hope you understand the solution. Like this video, subscribe the channel. Thank you.